quindi c'è tutto quello che serve, lasciamo libero e cominciamo quindi cominciamo da Kent Jackson. Thank you for a Capturing Carbon Project Urban Sequoia. Vorrei ricordare che SOM, Skidmore, Owings and Merrill, ha un settore ricerca molto importante. Allora, insomma, le società di progettazione che veramente spingono sulla ricerca, sia in termini di strutture, di involucri, di impianti, eccetera, non sono molto numerose. In Europa un esempio è OMA, con AMO, no? Che ha proprio una società ad hoc per svolgere ricerca, ma non è frequente. Questo è uno dei punti di forza di SOM, per esempio paragonato a KPF, dico io a Gensler, no? Facendomi magari qualche nemico, facendo altri due grandi nomi storici della progettazione architettonica americana. Ecco, SOM è particolarmente, e Dario forse può dire due parole, ma può dire due parole sull'attività di ricerca di SOM, perché l'ha seguita da vicino. Abbiamo dato anche una laurea honoris causa al Politecnico.
Sì, è stata un'attività che si è sviluppata nel corso dell'ultimo decennio soprattutto, attraverso una serie di analisi e di focus su dei temi in particolare, per cominciare dalle facciate, la sostenibilità, poi il tema è entrato molto più nello specifico sul tema del carbon, e questa ricerca, questa presentazione di oggi dell'Urban Sequoia rientra all'interno di un argomento che poi verrà trattato e affrontato anche da altri relatori, che è probabilmente una delle principali forze in questo momento. Certo, il settore dell'edilizia è terremotato dalla questione dei costi, ma il carbon e la decarbonizzazione è soprattutto nel lungo termine uno dei trend più forti ed evidenti che si possono riscontrare parlando con tutti i professionisti coinvolti nei diversi stadi della progettazione di un edificio. Non solo alto, ma chiaramente parlando di grattacieli, il tema diventa particolarmente importante.
Beh, poi la Sequoia, se non è altro una Sequoia.
All right. I want to say thank you for that introduction, even though I didn't understand much of it, but I hope it was good. I wanted to just say that, again, my name is Kent Jackson. I'm part of Skidmore, Owings & Merrill, based in London, originally worked in our Chicago office, and again, we are kind of this linked up interdisciplinary practice of around 1,400 people. And we do very much have a series of kind of like-minded designers that are trying to solve a lot of the problems that we see facing us today. And a lot of these are very, very difficult issues that are being put in front of us. And some of them very intimidating and concerning about where we see the health of the planet going. This is part of a project that we worked collectively across the firm to think about ways in which we could stop working the way that we've always worked and think about doing something completely different. And this is more of an ideas presentation that talks about what if. And I think the what if needs to be more, how do we make it happen today, rather than waiting 2, 3, 4 years as we see how things are changing so quickly. So I will start off with a video that we shared at COP26 in Glasgow, and then I will go into more detail with that presentation. So here we go. So I'd like to introduce you more to this idea that is really meant to change the way we think about the built environment and really the next generation of tall buildings. The idea is deliverable with the existing technologies that we have today, and it will allow our cities as well as our buildings to work in a similar way as our forests do. And as we're all aware, and as a lot of the speakers today have already mentioned in one way or another, we see that climate change is throwing the world's system out of balance. And it's also looking at the way in which we see the degradation of our ecosystems as we go forward. Equally, we're seeing these societal inequities in the way in which the world is moving forward. And equally, there's more and more economic disparities. So, as one of the slowest progressing sectors over the years, and the building and construction industry we see is really at this crossroads, we can no longer sit idle and think of these incremental steps that we keep making to meet this 1.5 degree change or even the 2 degree target that's there by the end of this century. Sorry, pardon me, losing my way. Today our sector is emitting much more carbon than nature can really absorb. And with 40% of its emissions going directly into the atmosphere, we're already seeing the impact of many of these issues. In many ways, people's lives and livelihoods are being altered. And we're also continuing to jeopardize the vitality of our community's economy and our environment. Our global population is growing at an alarming rate, and with the anticipated increase of 2.1 billion people in the coming decades, our cities will be placed in immense pressures. Our current global building stock is predicted to double by 2060, and our cities will be under great demand to see how we can actually meet this growth, and we can't continue to look at this in the same way that we have, or we can't really continue to work in this way city by city or country by country. It's the way in which the industry is working and the way it always has been done.
Which city is this? Sao Paulo? No.
You can't ask me those questions. Yeah,
You'll guide to us.
we'll go with Sao Paulo.
It's not Italian, no European.
Non-European, no. We'll come on more to some of the European issues
Yes.
that we face, but really the point being is that our planet at the current rate will not be able to carry on with this burden. So bringing it closer to home, we'll be constructing and renovating the area equivalent of the city size of Milan to the planet every week for the next 40 years. So this global alliance for buildings and construction highlights the need for all existing and new buildings to reach net zero by 2050. But getting to net zero is simply not going to be enough for us, and I'm going to now tell you the reasons why it's not going to be enough for us. We see a lot of charts. This is going to be one of the last charts you're going to see from me, but the environmental damage that we can see today is the result of a mere 1.1 degree global temperature rise since pre-industrial levels. And this current trajectory indicates that this rise could reach up to around 4.4 degrees by the end of the century, resulting in catastrophic consequences. In light of this picture, it's imperative for all of us to change this trajectory collectively. And the built environment plays a very critical role in how we're going to be able to make this change. And we really need to think about revolutionary thinking for us to really make the evolution of our sector. So it has been predicted that there will still be more than 50% of the buildings yet to be constructed by 2050. And it's essential that we have intelligent densification in our existing cities. And the problem is that it should really be obvious to all of us. We haven't really made any significant changes in our industry since the 1950s, where we've benefited from mass production, from really the Industrial Revolution, which made it far too easy for all of us to use materials abundantly, and it also made it use it very inefficiently. We are free also to be able to use heating and cooling at will, and rather than looking at passive solutions that we would have known pre-industrial revolution. And we've stopped needing to consider all the natural ventilation and insulation into our buildings. And I would say as an industry, we've really fallen asleep at the wheel. So the question is that if we could reimagine our cities in some fashion, and that we treat them as a series of interconnected ecosystems, where our cities could act more like forests, and where we could help our cities purify, heal, and regenerate, where urban forests could create a new carbon economy, offering a new resource and a resilient growth to our planet. Although a lot of people in the audience might be wondering, how do their organizations even meet the current energy targets? The built environment must do much, much more than our current ambitions that we're seeing in changing of codes and different city aspirations. We can no longer be talking about how we can achieve net zero. All of the statistics illustrate that we're just not going to be able to get there. This is sadly proving to be a clear fact. We need to be getting to our buildings to be carbon negative if we want to make a chance to make any of this changes and the planet be a better place for our future generations. If we could think more of how an individual building might respond like a tree, where we're able to absorb carbon from the atmosphere rather than emitting it, if we could better leverage our existing technologies or emerging solutions that are out there, could we find a way that we could have a future where our cities are populated with these urban sequoias? And by creatively integrating such technologies and solutions to our buildings, we can reimagine how we design and construct the built environment with the possibility of a future that's not only going to be carbon negative, but it's also going to be a regenerative one at all scales and also at all contexts. Our cities are rich in their fabric and the varying scales and the different type of building types that we have. They might either be a single-family dwelling or they could be the tallest building in the world that sit within our cities. But we need to find unique interventions in order to play our part in the sector's carbon negative future. Tying it closer to today's series of talks, high-rise buildings are, to me, inevitable component for our future urban growth, especially for rapidly densifying cities where the land is limited. However, this typology is the one that we really need to scrutinize much more closely, because I think all of us are aware there are significant both operational and embodied carbon impacts to tall buildings. And tackling these type of complexities for tall buildings will push us to find those other synergies between urban development strategies and their systems. And by being able to find these rigorous solutions to the building type, we can apply these innovations to other building typologies around the world. So hopefully also everyone's aware in the audience that there's really no silver bullet that is going to take us there. These are going to be a series of steps that we all need to take and look at the way in which we make this change. So when we looked at a high-rise typology, we found that it's possible to reduce whole-life carbon emissions by making a series of enhancements that are actually easily achievable today. As an example, by simply optimizing the building form, we can minimize the amount of material to reduce carbon emissions by around 15%. Also, by something that's been around since the 1950s, by taking 85% of our building and make it either prefabricated or in modular elements, we could be able to achieve clearly better efficiencies, reduction of waste, and we could limit the movement of both people and goods. And this will ultimately allow us for less pollution in our cities. And through these very achievable targets, we would again be able to reduce a further 15% of carbon in our high-rise buildings. And if we look at integrated building systems that are both passive and active, the tall building of 60 stories could have up to 30% carbon reductions. So with these advancements in material science and natural materials can offer low carbon and scalable alternatives. The example on the screen now is BioBrick, a very simple material made of local resources from anywhere around the world. So let's just think about this for a little bit here. That every country in the world that has access to sand, water, and algae would be able to take this and be able, in some of the fastest growing cities and the poorest cities, could be able to make their own building materials on site, and the material could be sequestering carbon. And this means we could be delivering solutions that are affordable for everyone and everywhere. Over the last 70 years, we have predominantly relied on only concrete and steel, two of the biggest abusers of embodied carbon. And I know there's going to be some great conversations later, but we're finally seeing that there's going to be significant changes in reducing the amount of embodied energy from both steel and carbon later. So, but we really need to see how we can be looking at alternative and materials that we can see that are sustainable solutions, such as timber or materials such as biobrick or biocomposites, that we can further reduce the building's carbon emissions by another 50%. When coupled with nature-based solutions, such as offerings, can deliver carbon-negative buildings at scale. And this is an algae facade, and if we take algae as an example, it's currently being explored as a source of energy, and its application is already being tested in building components, such as the example you see here. And when algae could be incorporated into a building, it can generate energy for its operations and produce biomass as an actual product. And with the integration of algae in a single building, we can reduce whole life carbon emissions by around 25%. And when solutions offered through advancements in material science and nature-based sources, and looking beyond our sector, emerging technologies in carbon capture, which are currently used in industrial processes, we can bring these technologies to our sector as a solution and dramatically accelerate the decarbonization of the building industry. So with the integration of carbon capture and storage into our buildings, we can then allow for another potential of reduction in carbon by around 75% in a single tall building. And through a collective application of all of these solutions and technologies, we can breathe life into our buildings and transform our industry into a catalyst of restoring the health of our planet. And in this vision, urban sequoias can collectively contribute to the regeneration of creating new carbon economy, where carbon can be traded. And this could bring a potential new stream of income to our cities as they grow, which could be applicable for all of our cities tomorrow. We should be re-envisioning the city as an ecosystem so that all of our cities can be able to be connected and be regenerative. And to take New York as an example, which has the highest carbon footprint in North America, with its new and very advanced energy laws, it could go beyond net zero into a carbon negative and even become a regenerative city. And imagine if we as a construction industry knew what we could reverse our current trend, and instead we could finally do more good than harm when we expand and grow our cities. It would allow us to populate our cities with urban sequoias and create a network of carbon capture, storage, and exchange. And to date, one of our main answers to carbon reduction has been to plant more trees. But as our population rapidly grows, we will not have time or the land area to possibly meet the required carbon offsets. The challenge ahead of us is going to be incredibly difficult, and it's going to be an immense pressure on all of our shoulders. But we propose to embrace innovation and collaboration within, but most importantly, beyond our sector. To create a global network of urban sequoia forests, we could save up to 1.6 billion tons of carbon a year. And this would be the same as covering the planet with 70 billion trees, and that would be the equivalent of covering almost all of Europe in trees. So I want to thank all of you today for your time, but I would actually plead with you that we do beyond our part to save our planet. So thank you.
Well, if we think of Amazonia, then we are immediately depressed. What's happening in Brazil?
We should be depressed.
No, we should not. We should fight for sequoias. But the answer is not planting trees is not sufficient. We have to change the buildings themselves. The answer is clear.